Hey everyone, welcome back to Cruise class. Now today's lesson will be our first introduction to differentiation. Now today's topic will first be understanding what a differential is and how it is related to graphical information. Now this is differentiation from first principle. A differential, first of all, is a gradient. And as we know, the gradient of any function is simply rise over run. A lot of us grew up hearing about rise over run. What does rise over run mean? It simply means the vertical rise, as in the difference between y1 and y2, divided by the horizontal run, which is the difference between x1 and x2. However, in this case, the gradient would be the gradient of the function at an instantaneous point, meaning the difference from x to x2 is so small to the point where it is almost approaching zero. Now, this is an exaggerated view, but really and truly, this distance here, which is represented by h, is an extremely small distance. It's almost as if you are moving on one singular point. So the point right here moved to right here. However, the distance is so small that it's almost an instantaneous movement. So that's why sometimes you may hear them referring to differentiation as instantaneous rate of change. However, this term, or rather this gap, is a small distance, h. So if this is x1 and this is x2, x2 will simply be the original x plus h. So to move from here to here, what we need to realize is that if x is right here and we add the distance h, it will give us our new x value, which will be x plus h. So this is x, we move a distance of h, so this is now x plus h at this location. Same thing is said for the y terms. So we represent it by saying f of x. So x would coordinate to f of x. Therefore, x plus h would coordinate to f of x plus h. So that distance is right there as well. So what's going to happen is that in order to find the gradient, it will be the vertical rise over the horizontal run. So it will be the difference between f of x plus h and f of x divided by the difference between x plus h and x. So we're going to minus these two and divide it by minusing these two as well. And then we're going to have this as the gradient. F of x plus h minus f of x divided by x plus h minus x. This is basically the same thing as saying y2 minus y1 over x2 minus x1. Good? Now with this, we can see that x will cancel x right here. So x minus x will cancel out each other, leave us with h alone, and the numerator will remain the same. So, as we were saying above, the change in x is so small, meaning this change right here. It is so small, it is so minuscule that h is literally approaching zero. Now, that simply means that the limit as h approaches zero will be the limit that we use when we're working on differentials. So we're going to assume that that distance is so small that it's approaching zero. So the limit will be h approaching zero. And because of that, the first differential formula, meaning when you're differentiating something, we're going to realize that the limit as h approaches 0 of the function fx plus h minus f of x divided by h. Because remember, once more, we said that x cancel x, so we'll be left with h. So we basically rewrite this entire formula right here. However, this time the denominator will only have h. And the limit is h approaching 0 because, as we said, h is so small that it is basically approaching 0. Now this is the principle, the first principle formula. So this is the basis of differentiation. Every differentiation, or every function rather, that you differentiate comes from this basic formula. Now we're going to look at a further video and see how we can actually apply this formula to differentiate a function. Now this has been the introduction to differentiation, and I'll see you next video.